Okay, well, graphing exponential equations. We're going to do a little light graphing today. Not too bad, not too terrible.
I don't know about that. What kind of marker? I need cough drops.
Go. Alright, so a couple definitions real quick. Exponential function, it is a function where the base is a constant and the variable is an exponent. Alright, so you're talking about, this is going to be weird today, you're talking about things like 2 to the x, 3 to the x, 1/4 to the x, stuff like that. Okay? Notice that the variable is in the exponent now. Okay, that's what an exponential function is. Now, one of the weirdest parts, and something we're going to take some time on today, talking about, is this word here. Be very, very careful when you say this word. It is asymptote. Okay? Asymptote. A-S-Y-M-P-T-O-T-E. Asymptote. The P is kind of silent. It's more like asym and then tote, like the tote you carry. All right. Asymptote is a line that the graph approaches but never crosses, and we'll talk about why that is on the next one. Okay, when we do our first graphing. And then they give you this box, and we can go through this box and talk about things, but it's easier just to talk about it once we do the first one. Okay. So just make sure you have these two written down for your definition purposes, and then we'll talk about them as we go. All right, everybody good? Great, next slide. So, first one. Graph, y equals 3. I'm going to add to these definitions, or to these directions. We're going to say state the domain and the range as well. Okay, state the domain and range. All right, now make sure you write that down on your paper because I'm going to go to my calculator app over here. We're going to get this guy loaded up and ready to go. So we're graphing 3 to the x, so 3 caret x. Plug that in, we hit graph. Okay, looks like that. Everybody see that? Alright, now like normally when you graph, you want to go to your table and look at your values, so we're going to do that next, so second graph. Now, as you move up and down this list, you're going to notice a couple of things, okay? Let's go first off to the positive side of things. Now, think about what you're plugging into. You're plugging into 3 to the x, okay? So you're plugging these into the numerator. So 3 to the 0 power naturally is going to give you 1, right? Because anything to the 0 is 1. Make sense? Everybody good? Everybody with me? Okay, good morning. Yep, all right. You plug in 1, 3 to the first is going to give you 3. All right, that makes sense, right? 3 to the second is going to give you 9. Okay, 3 to the third is going to give you 27. 3 to the fourth, holy crap, 81. 3 to the fifth is 243. 3 to the sixth, I don't even know off the top, it's 729. These get very, very big, very, very fast. Right? You're dealing with exponentials. You're shooting up really quick. So they get very big, very fast, right? All right, let's go the other way now. Let's go down to the negative sides. Now, when you plug -1 in, that's going to give you 0.33333333, also known as what? No, what fraction? 1/3. Okay, 1/3. When you plug in -2, it's going to give you 0.11111, which is also known as 1/9. -3 is going to give you what fraction works out as 1/27. To the fourth, it's going to give you 1/81. Okay? When you plug into the fifth, it's going to give you 1/243. When you plug in -6, and these are all fraction, not decimals, right? It's going to give you 1/729.
It is 1 over the
whatever, right? Okay. What number, though, will it never be?
0.
Never. Good. Good. It's never going to give you 0. Think about that. It's never going to give you 0. Because it's always going to just be 3 to some really large power, which will give you something that's very close to 0, but it's not 0, right? That's where this definition of an asymptote comes into play. Okay? It's a line that the graph approaches but never crosses. Okay? It's a line a graph approaches but never crosses. That graph, even though you can't really get a good picture of it because of the technology on the calculator, but this graph never crosses that 0, that x-axis. Okay? Obviously, it gets insanely close to it because you're getting, think about it, microscopically close, right? 1 to 729th. Close. And closer, and closer, and closer. To the point where, obviously, you're not going to be able to see it on the screen, but it never crosses that 0. See that? Okay? So whenever you go, whoops, wrong button. I need to go up here. There we go. So whenever you go here to graph it, okay, we have some points. We know it's what, when we plug in 0, we get 1, right? So we know we're right here. We plug in 1 and we get 3. We plug in 2 and we get 9, and we're right there. We know those 3 real good, right? But whenever we go to this side of it, we really can't, and I'm talking down here, we don't have any real nice points, right? We got -1 and 1/3, and then we got 1/9, and then 1/27th, and it just keeps on getting, like if I can draw, closer, and closer, and closer, and closer, and closer, and closer, but it never crosses. Okay? So when you go graph it, you have to make sure you do the same. So ride your pencil mark right along that x-axis, and then curve it up. Kind of like that. Okay. Obviously, now let's talk about this. Obviously, I'll use some discretion here. Okay, as far as your graphing along that asymptote goes. See how I kind of dip here a little bit? Okay, see that? I'm touching that x equals 0 line. Okay, I'm not too worried about that. All right, but what I am worried about, and I'll do this in blue. Hold on here. Let me get a blue. Okay, what I am worried about is if I see something like that for this graph. Okay, see how clearly you're across that line? See, that part's not good. Okay, so that's an example where you'll lose points. But something like this where you just touch it or you dip a little bit, you'll be fine. Okay. Now, there's 2 other questions I told you to write down. Domain and range. Okay. Domain is your x's, range is your y's. So what x's can we put into 3 to the x? Which ones? Negatives. We can put in just negatives. What about 3 to the first? Yeah, that works. 3 to the second? That works. 3 to the third? That works, right? So we can put in negatives, we can put in positives. Can we put in 0? No. 3 to the 0 is 1, so that works too, yeah. So can we put them all in? Yeah, so a domain is all real numbers. Okay? Your domain is all real numbers. Psst, here's a hint. For all of these, your domain's all real numbers. Okay. Okay, great. Okay? Now that range is what's tricky here. Okay? The range you have to be careful with. We know ranges are y. Okay? Now if you go over here and you look, and we already talked about what number this line keeps getting closer and closer to, and that line is what? Or that number is? No, keeps getting closer to which y number? Y of? Come on, guys. What did I just say? Why it doesn't cross? 0. Okay? You keep getting closer to 0. All right? So you're getting so dang tiny that you're not getting closer to 0. So anything that's bigger than 0, you can include, right? Because if you look at this side of the graph, you go from 0 up to 1, 2, 3, 4. They all have y values after that, right? A y value of 1, y value of 3, y value of 9, y value of 27, 81, all up the line. But you never go past 0. Do you ever hit 0? No. So here's a subtle change. This stays greater than, doesn't include 0. Okay? This doesn't include 0. You need just a strictly greater than sign on this. We used to always include 0. Or include whatever that number was. Now we don't. Okay, same questions. We're going to state the domain and range. We're going to graph it. So let's go back to my calculator here. Y equals, let's clear that one out. Okay, now you have to be careful with this. And as I told Accelerated this at the beginning, I think they kind of ignored me about it. So you need to become at 1 with your calculator this chapter. Okay, you and your calculator need to become best friends. Okay, which means you need to bring it every day. And I think I've said that before. Okay? Bring your calculator every day. This function is 2 to the x. And here's one of those things. Look at your PowerPoint or look at your notes. Is the plus 1 up in the exponent or down? It's down. Make sure you get it down in your calculator also. Because right now if I hit a plus 1, it's putting it up with the x. Okay? So arrow to the right. Hit plus 1. Okay, everybody good? Let's hit graph. Now what you're going to notice is all of these graphs are very similar to each other. Okay? They all basically have that same shape. It's just where will they be placed. Okay, but they all have that same shape. Now, let's hit the table. Let's look at these numbers. Remember, we're plugging into 2 to the x plus 1. So, plug in 0. 2 to the 0 is 1. 1 plus 1, 2. Okay, makes sense on why that's there. Plug in 1. 2 to the first is 2, plus 1, 3. Great, that works out there too. 2 to the second is 4, plus 1, 5. Everybody makes sense on this side? Okay? Then you keep going, you get more numbers. 3 is 9, 4 goes to 17. That's about all you can hit. Okay, so we'll graph those in a second. Let's go the other way. Let's check them out. We plug in -1, okay, and it gives us 1.5. All right, now let's not worry about the fraction of it. Let's just worry about the decimal part of it. 1.5, okay? Plug in -2 and it tells us 1.25. Plug in -3 and it tells us 1.125. Plug in -4, 1.0625. -5, 1.0313. -6, 1.0156. -7, 1.0078. -8, 1.0039. -10, 1.002. 1.001. 1.0005. What are we approaching? 1. Good. Doesn't go past 1. Because you can keep on hitting up and hitting up and hitting up. Miss Winterbauer, give me a negative number.
Negative.
Big. Not insanely big, but big enough.
Negative 22.
Here's what I want to show you. Good. Big enough. Perfect. Okay. -22, 1. -21, 1. -20, 1. -19, 18, 17, 16, 1. 15. That's what I want right there. 14. Okay. Look at what your calculator does. You eventually get so close to 1 that the calculator gives up on you. Okay. This is me saying the calculator is being lazy. Because the decimal numbers become so tiny that it doesn't show it no more. Okay, everybody see that? But just know this. This is where you have to be smarter than the tool that you're using. Right? Don't let the hammer outsmart you. Be smarter than the tool you're using. There's a whole bunch of decimal numbers past that. See, look at that. That shows you what the real decimal number is. That one too. And then that one. And then that one. And then that one. Oop, wrong button. Second table set. Okay. Haley, go crazy now.
Big?
Not super big.
Negative 75.
Still gives up. Because it's so dang tiny, you can't even write it in that little space here. See that? How it just says 1 now? And not 1 point whatever. Now, where that switches over, I don't even know, and I'm not going to try to find it because that could take all day. Okay? Now, what changed? Two things changed from your first problem to this problem. Okay? Right? Two things changed. One was the number that its base is, right? This one was 3. This one's 2. Okay? That's not a big player. What is your big player? That plus 1. That's your big player here, is that number. Because it moved everything up 1. Okay, makes sense? It shifted everything up 1. So that's going to shift that line that you don't cross, that asymptote line, up 1 as well. Okay? So when it moves it up 1, that means you have to make sure you move it up 1 when you go graph it. Okay? So when we plug in 0, here we get 0 and 1, or 2 to the 0 is, anything to the 0 power is 1, 0, and 2. That's what I meant to say. Let's get red back here. That looks good. 1 would be 3. 2 would be what, 5? 3 would be 9, so up here. And then this time you got to be careful because it's not crossing at 1. So you got to be real careful with drawing this guy. Okay? Like that. Then we'll do the domain, and we'll do the range. Okay, domain is what? All real numbers. Your range is y is what? Greater than 1. Okay, greater than 1. It's greater than the line you're approaching. Okay? Here's another hint. Here's another clue. Ready? I'll use bright green so you notice. Oh.
So if that number was 3, it would be greater than 3.
Yeah, it would. Okay? These all work out a very specific way. That's the way they work out. Okay? What's different?
It's going down.
It's going the other way, right? Okay. Yeah, it's going down. Yellow and timber, right? Okay. It's going down. That's what happens. That's what will happen whenever you have a fraction as your base. Okay? Now, it really doesn't change your purposes a whole lot as far as, oh, it's a fraction, you know? It doesn't really, it changes your numbers a little bit. For example, now if you look, the negative ones are where the whole numbers are at. Okay? You know, negative 2 goes with 9, negative 1 goes with 3, 0 goes with 1 still, and then it just basically flips it so that the fractions are on the other side. Okay? But other than that, for your purposes, it really doesn't change a whole lot. Okay? Just make sure you put in your calculator right, make sure you get your domain and range right. Okay? As far as that goes. Let's pull this one up here then. So if you plug in and you graph, we go 0 still gives us 1, negative 1 gives us 3, negative 2 is going to give us 9 way up here. And then this time, you still approach, 0, but you do it from the other way, okay? So then you do domain. Domain is still what? All reals. Never changes. And your range. Your range is what? That's a question. Yeah, that's gonna mess you up now, huh?
Do I flip the side?
No,
Okay.
because the y values you're still including are still what? All the y's that are greater than 0, right? Because even though this time when you read it from left to right, your line is coming from the skies and falling down, you still don't cross 0, right? The ones before, you came from the bottom and you shot to the skies, okay? But you're still not crossing 0. So this sign doesn't change on this example, okay? Does that make sense to everybody? Everybody okay? Okay, we're going to do one more today, and we're going to call her good. All right? We're going to make a subtle change to this one also, since Miss Pearson brought it up. Okay? Last one. I want you to strike that 2 out. I want you to make it a negative instead. Okay? So instead, make it y equals negative 1/4. Let's just change it all, huh? Let's just make it negative 1/4 x minus 3. Let's do that instead, okay? Just plug it in, okay? All right, like that. Negative, parentheses. Do a negative sign there, right? Don't do a minus, okay? Make sure you do the actual negative sign, not the subtraction sign. Your calculator won't like that, okay? It'll give you an error, syntax error, okay? Second thing, if you're going to be careful with these, okay? These can be a little tricky. If you plug the negative in here, if you put it in straight with no parentheses, it actually works better. Okay, it's one of the rare cases. If you do use parentheses around that 1/4, the negative sign has to be on the outside of those parentheses. Okay, as long as you do that, that's fine. I would honestly just put it straight in with no parentheses. It works out better. Okay, what changed? It went from the bottom and came up this time, right? See that? Okay. A couple other subtle things too change, with your numbers and stuff like that, and how you approach your asymptote this time. The other thing that hopefully you noticed is the amount of nice points that you have or the lack thereof. Okay? Because if you go through as far as what you can graph, how many nice points do you really have to graph? I see 2, right? -1, -7, and 0, -4. That's about it. You don't have a whole lot of nice points to graph here. And that can be common. Okay, don't freak out if you only see 1 or 2 points where these graphs go through whole nice numbers. That can happen. Okay, your best bet, honestly, is just make sure you don't cross that asymptote and do be accurate where you can. Other than that, I'm not going to check to make sure you go through 2, -3.063. I don't have a millimeter scanner where I'm going to search that and make sure you're accurate with that. Just make sure you don't cross that -3. Okay? So when you go here to graph it, whoops, wrong button up here, from current slide, remember we changed this, okay? Because I had to rewrite it. We have y equals -1/4 x minus 3. Your nice points, remember, were -1, -7, which I think is this right here, if I counted right. Oh, I didn't count right. It's one more. It's right there. And then 0, -4. Besides that, you really don't have any nice points except for the fact that you can't cross which line? -3. So make sure that you don't cross that -3 line kind of like that. Okay, once again, make sure you do your domain and range. Domain, surprise, surprise. All reals. And what's your range this time? Y is less than -3. Because you approach -3 from the bottom, and then you go down. So this is where your sign flips. Okay, that's where your sign flips.